Saya mengalung-alungkan kehadiran yang berbahagia Profesor Datuk Timbalan dan Chancellor Hal-Ehwal Akademik dan Antarabangsa ke majlis ini. Sidang hari ini yang dihormati sekalian, slot pembentangan seterusnya bertajuk Engineering Future Engineers. Dengan hormatnya dijemput Profesor Madya Dr. Hayati Abdullah dari Universiti Teknologi Malaysia untuk meneruskan sesi. Dipersilakan.
Selamat pagi. Terlebih dulu saya nak ucapkan terima kasih kepada Pusat Pengajaran dan Pelajaran Teknologi UKM, khususnya Prof sudi menjemput saya hari ini. Juga selamat pagi yang berbahagia Datuk PNCA. Nice to meet you again. Saya pun nak minta izin jugalah untuk bercakap dalam bahasa Inggeris sebab saya dah sediakan slide dalam bahasa Inggeris. Terutama sekali, tapi saya kena berhati-hatilah. Selepas Profesor Jaya tadi, I have to watch my English kan. Yeah. And also after the drama Akasia tadi, so engineering will be very difficult to keep up with the drama Akasia lah, yeah. So anyway, it was such inspirational to watch, to hear the three speakers. Professor Abing tadi, I've always learned a lot from hearing his talk, yeah? And it is such a challenge to keep up with him because he's always having something new to talk about, yeah? And Dr. Lee and Professor Daya, it's so interesting because what you have shown us, what you have shared with us, is so very much engineering. So very much engineering, yeah? So now I guess it's my turn to share with you, and I was invited in a letter of invitation. It says to share my philosophy of teaching. Yeah? I am an academician engineer. My name is Hayati, and I'm from the University of Technology Malaysia. And if I were to summarize my philosophy of teaching, it would be very difficult because I believe that my philosophy is manifested in how I dress, in what I do, whether it be in the classroom or outside when I practice. So I think I will share with you this slide here, and perhaps I hope that you would understand. Right. First, I would like to take a few minutes to share with you on what is engineering education and training. How are engineers produced in Malaysia? And that later will lead on to how and why I do what I do in the classroom as well as outside the classroom. Okay? Basically, a student undergoing engineering training in a university will go through 4 years of university education. Yeah? And when he graduates, then he's known as a graduate engineer, and that takes 4 years. Are there any engineering lecturers in this room, please? Can I see a raised hand? Okay, only on the left, is it? What about on the right? Education? Sciences? Yeah, engineering? Science. Okay. So anyway, engineering students go through 4 years of training. And to be accredited by the Board of Engineers Malaysia, cannot be less than 3 years. It has to be 4 years. Yeah? And after the 4 years, this is when I really sometimes am not very happy when the industry says we want ready-made engineers. You know, I think the university is where we provide, we prepare the students. And when they go to the industry, that's the next milestone. The industry is the one that transforms these graduate engineers into professional engineers. Because in the industry, after they graduate, the engineering student is supposed to attach themselves to perhaps a mentor. And that mentor has to be the same discipline. If you're a mechanical engineer, you have to find a mentor in your area. And he has to have professional engineer qualification, IR. And you go through 3 years of training. Yeah? And then, after 3 years, that's 4 plus 3 is already 7. And then, perhaps, you are ready to seek for your professional assessment examination. This is called the PAE exam. And then, if you pass this professional assessment examination, then you will carry the professional engineer status, or you can carry the title IR in front of your name and PN at the back of your name. And this is the engineers. Yeah? That means they have achieved a certain level of competency, okay, in their field. And the final milestone, because engineering is a serious business, it's a serious profession. There are some engineers whose work impact the lives of people. If you wrongly design the building, the ceiling might just collapse, and people's lives are at stake. So that's how serious it is. So therefore, those engineers, especially CNS, civil and structure, or those who deal with pressure vessels, before you sign a drawing, you need to have a practicing certificate, and that is what. And you have to take the professional competency examination to get that practicing certificate, and that will allow you to submit drawings to authorities for approval of your project. And I tell my students, as an engineer, when you sign a drawing, you're signing your life. You're signing your life. Because you are responsible for the rest of your life. You are responsible for the rest of your life. There is no expiry date. Yeah? So that's how serious this profession is. And this is where I come in. Because when I teach, this is what I have in mind. At the end, when you have that chalk that says you can endorse documents and drawings for submission of projects, that is the ultimate for an engineer. It's like a PhD for an academician. So when I go to my classroom, this is what I bring with me to the classroom. Okay? So if when they come to the first day of my class, I ask them, if you're looking for an A, if you're looking for an A in my class, you're in the wrong class. You're in the wrong class. Because I don't give grades. It's the knowledge, it's the understanding of the fundamental knowledge that's going to carry you all the way through this perhaps minimum 10 years before you can actually get that seal. Okay. So I guess that describes my philosophy of teaching, because that's the ultimate. So when I go to class, this is the kind of engineers I want to produce. Okay? So now that you have an understanding of what engineering is about in Malaysia, yeah? So what do we deal with, engineers? We deal with products, we deal with processes, we deal with systems, and it is always in a dynamic environment, always changing. Technology changes so fast, yeah? And society imposes a lot of demands, yeah, on engineers. So what do engineers do? We solve problems. Yeah? But we solve problems with limited resources. And in order to solve problems with limited resources, engineers have to be creative. They have to be innovative. Yeah? And so engineering is actually a creative and innovative profession by design. Yeah? By our definition of being an engineer, we have to be creative, we have to be innovative, because we have to solve problems with limited resources. So let's look at the scope of engineering. Because you're going to teach. If you are a teacher in engineering, you're going to teach engineering students. So let's look at what they have to do outside in the real world. They have problems. They have to identify the problems. They have to conceive the idea. They have to design and analyze. And then they have to implement. They have to plan, implement, and operate. And these all you can classify as under project management and site work. And to be a professional engineer, there are specific requirements. There are specific requirements. For instance, if you are a mechanical engineer, you need at least 6 months of design experience. You need at least 12 months of project management experience, and you need at least 12 months of site work experience. If you are a civil engineer, everything is 12 months. Right? And of course, when you do an engineering project, you deal with vendors, you deal with suppliers, you deal with contractors. So integrity is such an integral part of being an engineer. So all this, bearing all this in mind, you design how you conduct the classes. So what do they need? What do they need to be able to do all this work? When I go to the industry, and I ask them, what do you want from our students? Almost everybody will tell me, the first thing they will tell me is, we want students with strong fundamentals. Engineering science, physics, mathematics, and of course their disciplinary knowledge. And they must of course be able to solve problems, they are engineers, so they need the personal skills. And they must be able to communicate their ideas, so they need interpersonal skills. And the engineering skills, this is why I call it the engineering skills. And of course, bear in mind, they have to also consider society, they have to consider the environment, business, finance, and law, legal aspects. All this. So, engineering, is always, we work in a dynamic environment. So for the future engineers, this new breed of engineers, Dr. Lee mentioned the 21st century students, yeah? So the new breed of engineers, these are the list, a very long list that they have to have, the attributes that they have to have. And do you think we can do that in 4 years? Do you think we can do that in 4 years? Yeah, and then the industry expect a ready-made engineer. Okay? So what can we do? What can we do? What knowledge, skills, and attitudes should these students possess as they graduate? And at what level of proficiency in addition to what we have right now? What can we do better at ensuring that students learn these skills? Especially with the time that we have. Research university, impact factors, quartile 1, quartile 2, right? Funding limitation. So what can we do? Are we going to revamp the whole curriculum just to make sure we get this 21st century breed of engineers? What can we do? Do we know if you are engineers who solve problems, do we know what new problems then future engineers are going to face? Do we know that? Do we know the problems? Do we have the solutions? Do we have the answers? Does the engineers in Kelantan know that the big flood is coming last year? Did they know that? But now, after the flood, I'm with the Institution of Engineers Malaysia. So I met the chairman of the Institution of Engineers Malaysia in Kelantan. They're doing a lot of effort now, paperwork, proposals to the government, local and federal, on how to, flood prevention measures, etc., etc. So what can we do if we don't know what the new problems are going to be? I think if I were to quote Prof. Amin, he says that, how do you prepare students for a future we cannot clearly describe? Right? I took notes just now. I remember former Prime Minister of Singapore, Mr. Goh Chok Tong, he said something. He says, we may not know what the new problems are, but we must ensure that our young can think for themselves, so that the next generation can find their own solutions to whatever new problems they may face. And this is what has been highlighted by Dr. Lee, by Professor Jaya. Think. Yeah. So, if you look at this scenario, again, to me, if we want to prepare them for a future that we cannot clearly describe, then they must have strong fundamentals. With strong fundamentals, then they can be adaptable. You can put them anywhere, but they must have strong fundamentals. And as engineers, they must be able to do what engineers do, and that is conceive, design, implement, and operate. So Dr. Lee, what your students did was, I'm sure, the CDIO thing, right? Okay, and again, future engineers will have to deal with complex engineering system, and they have to work in a team-based engineering environment. So these are the things that I foresee that should be focused when we are looking, because the theme for today is to rethink teaching, rethink learning. Yeah? So to reframe engineering education, strong fundamental, integrated with personal skills, emphasizing thinking, interpersonal skills, product, process, these are the engineering skills. So, how do we do this? Our curriculum is filled to the brim, right? Cannot do anything. If you delete something, somebody was going to get angry, right? But we need this. And I feel that something that I worry is that I was talking to one student last semester, and she was telling me she's got like 6 subjects, and she's got like 3 to 4 projects, big projects, which means that she has to work with 4 teams, yeah, 4 big projects, and it involves the industry, so she has to go out to 4 different industries. Okay, I think we are all excited. You know, we learn about active learning, Center of Physical Learning, right? They give all these courses: active learning, experiential learning, PBL, problem-based, project-based. So we are all excited, you know, so we go out and we go back and we do this in our classroom. Everybody does this. Did anybody think about the student learning time? Did anybody think about the student learning time? Right? And I think even if they work in the real world, and we want to try and do real world problems in class, right? Even if they work in the real world, do you think they will be working with 4 big projects at one go? Right? And everybody is assessing team working. Everybody is assessing communication. When did we teach them team working? Where did we teach them team working? Right? So this is where I think, I think that we need to relook back at our curriculum as engineering education, and see how we can structure so that we have an integrated learning. But we know that there is a place where we teach team working. There is a place where we use team working, and there is a place where we assess. Not all the subjects have to teach the same thing. Not all subjects have to use the same thing. Not all subjects have to assess everything. Yeah? And why not talk to the English teachers? So that when they are doing videos, why not do videos on engineering if they are servicing to the engineering students? Yeah, Prof. If you are servicing the engineering, why not do videos on engineering problems? Right? You can talk to the engineering guys, you can collaborate, you can integrate. So this is how I see the future of engineering education. Integrated curriculum, integrated learning experiences, but well planned, well integrated, well weaved into the existing curriculum. Right? So this is where I came across CDIO. What Dr. Lee showed, the example is her students did, Prof. Jaya students did, they're all in line with this. This is something that I came across. Yeah? It's conceive, design, implement, operate. Of course, it was first conceived by MIT, yeah, and it's meant for engineering education. Yeah. So it is so much in line with what I have in mind. Look at CDIO, that's what it's called. It has two main components. One is the syllabus. And if you look at the syllabus, it's very much to what I have in mind. I've always had in mind, but never able to put it in words. CDIO gave me the answer. And CDIO also have standards. The syllabus is the knowledge, the standard is how to go about doing it. And if you look at that, they share the same philosophy as OBE. Engineering, we are big on OBE. No OBE, no accreditation, right? So CDIO shares the same philosophy as OBE. Right? So we are doing the same thing, but we're doing it better. But CDIO is like a cookie cutter approach. It's not a prescription. Yeah? We can translate, we can transform it to fit the context, even if it's not an engineering program, even if it's not. You take what you want, transform it as you wish, give it a new name if you like. Or we have a CDI group in UTM, we tend to go silent because every time you say something new, not another OBE, is it? Right? So we tend to go silent. We just say this is CQI. Okay? Quality improvement. And CDIO provides that tool for us to work through that process. I'm going to share with you some of things that the CDIO group in UTM has done. Some of them are done by me and some of my colleagues. I must give credit to them. Yeah, I will tell you which is which. But just to wrap up, to me, strong fundamentals is important. There's so many teaching and learning methods to do that. One that I use in class to make sure that the students do get it is I use concept questions. This was introduced in peer instruction by Professor Eric Mazur. Yeah? So this is something that I use. Professor Jaya, you are not allowed to take part because of the question. This is my telephone number, okay, to be used for this class only, all right? And this is the question. So concept questions is to test. You can do this immediately in class to know whether the students understand or not. Because understanding is fundamental to everything. Okay? So it can also be used to detect misconceptions. Yeah? Misconceptions. So when you design the questions, the answers, not tricky answers, but they are similar but not exactly the same, and the students have to think. Yeah? For example, this one question is not on engineering, but it's on education. Professor Dara mentioned metacognition, so I'm not going to ask him to answer this question. So if you believe that metacognition is important, you would provide A, lecture notes to students before class, B, opportunities for students to reflect on their learning, C, learning environments that promote collaboration, D, I have no idea. Okay? If you have something sophisticated, you can use clickers in your classroom. Yeah? Or if you have a good Wi-Fi connection, you can use learning catalytics. They will allow you to do the voting, and they will give you statistics and whatnot. But I don't have that luxury. I use low-tech, low-cost. So everybody has a handphone, right? That's the reason why I gave you my handphone number. And WhatsApp is free. So if the students don't have credit, they can share. Right? So this is one way, one of the things that I use in concept questions. And there are a lot of inventory. So you can Google, go to MIT or Harvard, and you can find these concept questions, especially in the areas of sciences, physics, chemistry. There are lots, so you don't really have to design them again. So this is the concept questions. It was so interesting to see Prof. Jaya doing the video, right? Very, very interesting. So I use the same concept as well. I use the same question because I focus so much on fundamentals. I want them to understand. And if I were to put back Professor Amin's learning pyramid, he showed us the learning pyramid. And if you look at the very bottom, 90% retention if they can teach others. Right? So you say teaching is not equal to learning. Right? But for them to be able for them to learn, they must learn so that they can teach, isn't it? They must understand before they can teach, right? So this is the concept that I use, and I use video as well. Important concept. For instance, before I would teach them the second law of thermodynamics, or how a refrigerator works, after the term break. So during the term break, I asked them, okay, go home. I have a happy holiday homework for you. I want you to do a video using your handphone only, no time or cost. Less than 3 minutes, yeah. But you have to learn. You have to read first. It's very difficult for students to read, yeah. I did a survey in class. I asked for about, I think, 2 years, 4 semesters. Why don't you want to read before you come to class? Because to do peer instruction, the students need to read, or just in time learning, whatever. So they refused to learn. So I asked them why, right? So there are many reasons that they gave, and there was one question: what would make you read? And of course, the answer is the quiz. So then I turned everything into a quiz. So I said, okay, you do this video, it's equivalent to 1 quiz marks, okay? Now, they have to read and understand the second law and how a refrigerator works. And I want them to teach, and I call that the project My Grandmother's Refrigerator. Go home, get your grandmother or your mother, and teach them how a refrigerator works in the vocabulary of thermodynamics, okay? And if they can explain, yeah, you get full marks. Okay? So this is one of the video that I would like to share with you. The mother is explaining how a refrigerator works. If only you can hear it. Itu ayam dalam tu. That's the evaporator. That's the condenser.
Dan apabila kita mengawal suhu tersebut, kita adalah sebenarnya mengawal komponen tersebut, seberapa banyak haba yang perlu disebut supaya suhu di dalam tersebut sama seperti yang telah diketahui.
It's fun. Yeah? Okay. And then there are some mothers who take it very seriously. It's like taking an SPM exam. Really make notes.
Saya nak menerangkan tentang peti sejuk. Peti sejuk ialah sejenis mesin yang memindahkan haba daripada kawasan bersuhu rendah ke kawasan bersuhu tinggi. Peti sejuk terdiri daripada 5 komponen. Komponen penting.
Komponen
seperti penyejuk, penyejak, pemampak, conditioner dan penginjak. Pengembang. Proses penyejukan mula-mula berlaku apabila haba di dalam peti sejuk disedut oleh penyejat. Haba yang terkumpul di dalam penyejat memanaskan cecair. Penyejuk menjadi uap. Pengembang agar suhu uap berkurang dan kembali menjadi cecair. Cecair penyejuk dihantar kembali kepada ke penyejat dan proses ini bermenang sampai
bila because it's close again. And some others are really creative. Oh wait, I allow them to submit in Indian language, in Mandarin, in Arabic, yeah, I allow them, yeah, and I also allow them to submit in Terengganu slang.
Itu saya faham pasal termodinamik ni ialah tenaga tak boleh dilakukan, tapi boleh berubah ke bentuk atau ke benda lain. Contohnya bila kita masuk air, guna pemanah air, tenaga yang masuk adalah tenaga elektrik, lepas tu tenaga elektrik tu akan bertukar kepada tenaga haba. Tenaga haba tu pula akan panaskan air. Lepas tu, elektrik tadi tu akan bertukar menjadi tenaga dan bilang ke alam persekitaran.
Okay, but there are some others who are creative.
Simply we talk about the energy. The energy is scatter. Then when I mean the water energy is scatter.
Internal energy. Look at Mother talking about internal energy.
The energy of the water will increase. And the stove heat the water makes the energy increase, and the energy will change to the hot stove. So after the water boiled already, the water already put somewhere in the cup, and anyway, the hot water will turn to cold because the energy from the water will goes surrounding or inwards. We make the water cool. It's simply to show that you cannot create the energy or destroy it, but the energy can transform from the other forms to another form. Let's say from cools to the hot and to the cool.
So, mothers can now explain the first law of thermodynamics. Of course, that was the amateur. Now you see the pro lah. This is a project in MIT.
Hi everyone, I'm Hayati and I teach thermodynamics at the Faculty of Mechanical Engineering, University Technology Malaysia. Today, we're going to learn about energy conversion in generating electricity. First, let's take a look at the scene of shadow play.
Bos tu sakti, oleh kau kuliah tinggal sampai aku. Lebih baik adina motor terisi Dewi Puluh dapat pada aku.
Which uses flat articulated figures to create the impression of moving humans and other three-dimensional objects. The name wayang kulit is also the name by which shadow puppetry is known in Malaysia. In this country, such puppetry usually features mythical stories and tales of morality. Malay shadow play between shadow play performance and our lesson of energy conversion. We shall discuss the association after watching this scene. Hence, it's...
Kamu pula ni, mana cerita ni? Kamu pula tak lampu ni. Oh, lampu mana?
Can you tell me what just happened to the boy and his friends? It seems that the boy does not have enough energy to light up the bulb for their play. Do you think we can help them? If you think...
Okay, I'm finishing. Alright. So, that's using videos. And also, in doing the conceive, design, implement, and operate the CDIO, so we have projects as well. This is one project, it's called the egg transporter. Somebody mentioned design thinking this morning, Prof. Amin. So we use design thinking in our projects, especially design projects. So this is the process of design thinking where you go through the understanding phase, creating phase, and delivery phase. Of course, there are a lot of other sub processes to this. Yeah. So this is an example of an egg transporter that was designed by the students. Yeah. Very interesting designs. Integrated learning experience, where you include active and also experiential learning. This is where you incorporate their process and life skills, their knowledge, the engineering knowledge and values and ethics. So everything is integrated together in this project, which I call Save the Fish. Yeah? How can Save the Fish be related to thermodynamics? Yeah? So the video that I showed earlier on the wayang kulit and everything, at the end, there was a visit to a power plant. The data from the power plant is what I use in this project. So it's real data. And they are supposed to design something, a power plant, in which the local authorities, and they are supposed to convince the local authorities that the discharge to the seawater will not be harmful to the environment. That is why the project Save the Fish. Yeah? How is that related to thermodynamics? Yeah? So of course, in planning, I will give them the project very early in the semester. And then I will take them to the power plant. See how excited when students actually go to a power plant. Yeah? And we have a lecture by an engineer, power plant engineer, in the power plant. And they get to see that a boiler is not a rectangle in the textbook. A boiler is as big as this building. Okay, and they get to get real data, and they interact with the engineers to get the data. Yeah? And then they complete their project. Okay? Because I promised the students on the very first day, by the end of this course, if I were to put you in the power plant, you will be able to perform, you will be able to function in the power plant with the knowledge that you will learn in this class. So at the end, they were able to design the power plant using real data from the industry. So that's the integrated learning experience. Nothing beats experiential learning. And another thing that I would like to emphasize on, is team-based. Teamwork as an engineer is so important. It affects the success of a project. Yeah? 3 factors affect the success of a project. Your own effort, the effort of people you depend on, and the way you work together. I share with them my experience as a practicing engineer. Whenever I go, I never go alone. I will always bring a team. This is my mechanical engineering, my mechanical engineers, and this is the mechanical engineers, these are the electrical engineers. But guess who's the leader lah? But nonetheless, teamwork is so important. So we teach teamwork to our students. In projects, this is not my students, this is a primary school. It was a big challenge teaching primary school students, let me tell you. But they must learn how to appreciate, working in a team. I gave them, to these primary school students, a challenge, building a tower using spaghetti and with a marshmallow on top. So the tallest structure will be the winner. And, believe it or not, the youngest one got the tallest. This is from year 7 to year 11. The youngest group were able to did the structure using the spaghetti and the marshmallow. So I call this a marshmallow challenge. So even in quizzes, Prof. Amin mentioned quizzes. Is this how we conduct a quiz in class? This is how you conduct a quiz in class? Yeah? This is how I conduct my quiz in class. Yeah? If you notice, there is a pink sheet and there is a blue sheet. The pink sheet is when they do the quiz individually, because there has to be individual accountability, right? So they will do this, the quiz first, using the pink sheet, and that will constitute 50% of the marks. And the blue sheet is where they can do in groups. They can go from one group to another, they're free. So my quiz is really a noisy class. Okay? And they not only do this in the classroom, they take it out as well, and this is where we have peer tutoring. In class is peer instruction, outside the class is peer tutoring. This is a candid, they didn't see me take this photo. Okay? This is important because Faisal here represents Malaysia in a martial arts competition. So Shazwan will tutor him, and also this international student. So this is what I call as peer tutoring, and I use that in class a lot as well. And of course, finally, I believe that it is the role of the teacher that you cannot just ignore, yeah? Because we are the one who's going to bridge the gap between theory and practice. This is why when Prof. Jaya mentioned school attachment, for the lecturers at UTM, there is a requirement for them to go for 1 year for the industrial attachment. And let me tell you, it makes a lot of difference. It makes a lot of difference to their teaching and the students' learning if they have the industrial exposure. It makes a lot of difference. To me, it makes all the difference. It makes all the difference to inspire the students, to motivate the students. Yes, Prof, I mean, Google is there, but the Google can show how a boiler looks like. They can tell, they can show a simulation, animation of the boiler, but Google cannot give you the feel of the temperature in the boiler. Prof, that comes from the lecturer. So with that, thank you very much. I'm sorry.